Welcome back, Science 10. This is the first inquiry lab, angle of incidence and the rate of temperature change. So as mentioned in the previous assignment, by looking at the material we've done so far here, this section here involving energy relationships in the biosphere, you should be able to look at, on this assignment, which is later on in the booklet, you should be able to answer questions 1 to 3. Number 4 deals with the next section right after the inquiry lab, so you should be able to do these 3 questions here. Okay, and they're fairly straightforward. Okay, so if we look at the angle of incidence and rate of temperature change, so the question, how does the angle of incidence of radiant energy affect the rate of temperature change along a surface? So hypothesis, you can make a prediction. So the little setup will look something like this. So of course this represents the equator, light hitting the equator head on, and at different angles, this would be kind of where we live, and this would be at the North Pole. So just imagine this. The tilt here represents the different areas on the Earth that are being hit with sunlight. Variables, which is the manipulated variable in this experiment? So what are we changing? And the angle of incidence or the rate of temperature change. So of course here we're looking at changing the angle of incidence and looking at the resulting temperature change. Procedure, so I've cut out 3 of these black strips. Black is of course a good absorber of energy, so it'll help the thermometer absorb energy. And then we'll be directing radiant energy from a lamp onto the pocket at angles of 0, 45, and 9 degrees to represent equator, northern hemisphere, or I guess southern hemisphere, doesn't matter, and the North Pole or South Pole. Create a data table that will allow you to record the temperature inside the pocket every minute for 15 minutes. Place the pocket on book so that it's level with the lamp. Make sure that it's 30 centimeters across, so we'll have to ensure that. Make sure the bulb is at least 30 centimeters away. Place the thermometer or temperature probe inside the pocket, so we'll have a thermometer here, ensuring that the black paper surrounds the bulb or the probe. Record the initial temperature inside the pocket, then turn on the lamp. Measure and record the temperature every minute for 15 minutes. Then repeat those steps at 45 degrees, then repeat it again at 90 degrees. Switch off the lamp and you've completed your investigation. So what we'll be doing there is these 7 questions here. Identify the manipulated variable. So what was the variable that you changed? And what is the responding variable? What is the thing that changed as a result of your change that you made over here? So identify those 2 things. 2, what are some things that we held constant throughout the experiment? So we tilted it, but what are some things we made constant? Why is it important to do that? Why is it important to keep all those other things constant except the thing that we're deliberately changing? Create a line graph of your data. Use solid, dashed, or dotted lines to represent different colors. So yes, we'll be making a graph with those 3 sets of data on it. And then number 4, describe how the angle of incidence affected the rate of temperature change. 5, identify the angle of incidence that exposed the pocket to the most radiant energy. Which angle exposed the pocket to the least amount of radiant energy? Describe the evidence you used to come to your conclusions. Number 6, consider your experiment as a model of Earth. Describe the consequences of the angle of solar radiation incident on average temperature at different latitudes on Earth, using your data to illustrate an answer. And then 7, in this experiment, the black paper absorbs most of the radiant energy from the lamp. Design an experiment that would allow you to test whether the rate of temperature change of a substance that reflected more radiant energy, such as another color of paper, was affected by the angle of incidence in a similar way as the black paper. Include a hypothesis in your experimental design. Now, in terms of that, you don't have to tell me everything, like I presume it'll be the same type of lab, but I'm more concerned about what do you think will happen. So if we use, let's say, pink paper, how would the temperature changes look, do you think? Would we get the same kind of results that we do from this one? So just comment on that in a few sentences. Okay? So you do have a science independent investigation sheet, so we'll fix it up so it's geared towards this lab. So angle of incidence and rate of temperature change. What do you want to find out? So of course that's equal to the problem that we discussed over here, or the question. Hypothesis, what do you think will happen? So after looking at the section that we talked about, what do you expect in terms of temperature at 0 degrees versus temperature changes at 45 versus 90. So what do you think will happen there? Explain what is meant by angle of incidence as it pertains to this lab. For here, we can cheat a little bit and just simply say the materials, well, as per text. The procedure, as per text. Safety rules, as per text. So whatever we looked at there. The 3 data tables, you should copy out something that looks like this. So angle of incidence at 0 degrees, angle of incidence at 45 degrees, angle of incidence at 90 degrees. So we're going from 0 to 15 minutes, so we should look at that and copy that out. So just, you can make your table similar to this, but just make sure you have room for, I guess, 15, maybe 16 data points that we can have there. So one table representing the equator, 0 degrees, one represent the northern hemisphere, and one representing the poles. Then lastly, the conclusion as we always do it. What were you going to do? What did you think would happen? What did happen? So the purpose was to da-da-da-da-da. It was thought that da-da-da-da-da would happen, and then what actually happened? Was your original prediction right or wrong? And then lastly, answer your questions 1 to 7 from the handout on the graph paper, or loose leaf. Likely loose leaf would work out really well. So those 7 questions, of course, are these ones here that I just referred to. So 1 to 3 and 4, 5, 6, 7. Okay. Also, if you want this graph here, you could do, if you find that this room here, or there just isn't enough room here, you could do it on loose leaf too, which is somewhat set up for this already. Okay, we'll see you again.